Hi guys, this is Teorix, I'm Arash.
And I'm Puya.
If you want to know more about more complex RC circuits,
Watch this video till the end.
Now I would like to draw the schematic of the circuit that we have shown you guys in the intro. And as I've written, all the capacitances are in microfarads. So now I would like to just simplify what I've drawn. First, this part of the circuit is going to be simplified. So, as we can see, we have 4 capacitors with different capacitances, and in order to just simplify, and we know that they are in parallel form, so all the capacitances are summed up. And now, in the next step, we just put one capacitor instead of all these 4 capacitors. And now we can calculate this part of the circuit. I want to simplify this part. As they are also parallel, their capacitances will sum up. After these calculations, if we want to just calculate the third part of the simplification, we can draw the circuit like this. So in this part, we calculate the third section of the simplification. As they are in series form, 1 over 220 plus 1 over 110 equals 1 over C3. Therefore, C3 equals 220 over 3, which is... And in the next part, I draw the last circuit for the simplification. For the last step of the simplification, there are 2 capacitors in parallel form. So equivalent capacitance is the sum of the both capacitors. So 73.3 plus 38.3 equals 111.6. So all the capacitors can be simplified to one capacitor, which is a capacitor of the value 111.6 microfarads. This is the equivalent capacitor that we have. You might ask yourself why we have done this process. The main important answer to this question is that sometimes we may not have the adequate and appropriate capacitance. With the equations that we have told you in the previous videos, you can simply make your own capacitance with the normal capacitances which are available in the store. In this part, I would like to calculate the total resistance of the circuit. Now this is the schematic of the resistors, and we want to simplify this circuit. Now if we want to calculate the total resistance of this part of the circuit in a faster way than the usual, we know that these 2 resistors are parallel, and the equivalent resistors is the 10 kilo ohms. These 3 are in series form, so the equivalent resistance is these 2 are 10, and this, the above, is 20 kilo ohms. And now we know that these 2 resistors are also parallel, and the equivalent resistor is 10 kilo ohms, and all these 3 are in series form. So all the resistance equals 40 kilo ohms. And now here the total capacitance is 111.6 microfarads, and the total resistance is 40 kilo ohms. So if we want to make the circuit as simple as possible, we have to draw something like this. Now we would like to calculate what does this voltmeter show. So we know that this circuit can be simplified to a capacitor and a resistor. And we have calculated that this capacitance is, and in our previous videos we have told you that the voltage change across these 2 points or nodes can be found out by the formula V of C equals V0 multiplied by 1 e to the power of, right? So now it's the same as before, and we can see that these 2 nodes here are exactly these 2 nodes here. So we know the voltage change across these 2 points. One more thing we have to mention is that when 2 capacitors are in series form, and we have a, for example, here is connected to the ground and here is V volts. If we want to calculate how much voltage, how much of the total voltage is on this capacitor and how much of the total voltage is on the second capacitor, we have to know that in the capacitors which are in series form, the total charge on C1 equals the total charge on C2, right? Because if there's a difference, then there will be a current flow. So as there is no current flow, so it means that the charges are the same. So we know that Q1 equals Q2. We want to calculate the ratio of the voltages of C1 and C2. So we know that the voltage across C1 is Q1 equals C1 V1. Therefore, V1 equals Q1 over C1. And the same for C2. And also we know that V1 plus V2 equals V. Now we calculate the ratios. As we know that Q1 equals Q2, so these are gone. And now we know that V1 times C1 over C2 equals V2. We know that V1 plus V2 equals V, and also V2 equals V1 C1 over C2. So we substitute this formula to the above, and we get that V1 plus V1 C1 over C2 equals V. V1, we just factorized V1, and 1 plus C1 over C2 equals V. Then V1 times C2 plus C1 over C2 equals V. Therefore, V1 equals V times C2 over C1 plus C2. And for V2, we have V times C1 over C1 plus C2. And now I would like to calculate what actually the voltmeter shows. Now we know that VA minus VB equals VC. From the previous page, we know that V1 equals VC times 110 over 220 plus 110, which is VC over 3. And V2 equals 220 over 220 plus 110 equals of VC equals VC multiplied by 2 over 3. Now we know that what actually VC is. So V1 equals V0 times 1 minus e to the power of t over RC over 3. And V2 equals 2 times V0, 1 minus e to the power of minus t over RC over 3. So now, as we know that it's an RC circuit, we know that it has a time constant which equals R times C. And you can find the link to our RC time constant from the top right corner of this video. We know that this amount I mean the time constant equals 4.464 seconds. We also know that after one time constant, the capacitor is charged by 63.2% of the maximum voltage, and after 5 time constants, it's nearly full. So we know that our circuit is something like this. And we know that VA minus VB equals VC. So due to our calculations, we know that C1's voltage is V of 1 equals V0 over 3. And we consider V0 as 12 volts. Therefore, the maximum voltage of C1 equals 4 volts. So, after one time constant, we know that 63.2% of the capacitor is charged. So, which means that after one time constant, the voltage is 2.528 volts. And after 5 time constants, it's 4 volts. Let's test it out. And now in the experiment section, this is the part which is for the capacitors, and this arrangement is for the resistors, and the voltmeter is connected across the terminals of this capacitor. And now we are going to connect this circuit to the power and see what happens. Be sure you hit the subscribe button and let us know your comments. Thanks for watching.